Chadwick Helmuth, the world leader in dynamic balance equipment, introduces the Vibrex 2000, a state-of-the-art propeller and helicopter balancer and analyzer. It's portable, it's rugged, it's reliable, and it's accurate and fast.
It's accurate and fast. I usually count on a balance prop and one set of adjustments.
The importance of propeller balance was recognized early in aviation. There is no difference in the static balance of propellers of yesterday and today. Dynamic balance, however, is a comparatively new development, creating increased safety, comfort, and utility for propeller-driven aircraft and rotorcraft worldwide. A dynamically balanced propeller decreases vibration, enhances comfort, reduces noise, increases safety by reducing component stress, and lowers operating costs. The Vibrex 2000 offers a reliable, profitable service for FBOs and lowers maintenance costs for operators. Enjoy the benefits of dynamic balance and fly with confidence with the Vibrex 2000. All new and overhauled propellers are statically balanced. This method uses gravity to determine the heavy spot on the propeller. During build-up and installation, there can be considerable weight stack-up errors, which result in out-of-balance conditions. The Vibrex 2000 is a tool used to analyze and correct out-of-balance conditions on propellers and rotors on the aircraft, with the propeller or rotor in its operating environment. Let's look at the Vibrex 2000 kit in detail. A velocimeter senses the motion resulting from the orbit of an out-of-balance propeller. Mounted close to the plane of the rotation of the propeller, it converts this motion to an electrical signal to determine the amount of vibration. Occasionally, out-of-balance is produced by the crankshaft, not the propeller. To be sure that the crankshaft is not a problem, a second or check velocimeter is mounted on the rear of the engine, so the progress of balance can be monitored along the length of the drivetrain. A photocell sensor is installed to measure the speed of the propeller and provide a timing pulse which is used to determine the phase of the out-of-balance. A single retroreflective tape is placed so the beam from the photocell hits the tape. The retroreflective tape is aligned by the illumination of a red LED in the rear of the photocell. To illuminate the LED, hook up the photocell lead to the balancer and turn the balancer on. Proper alignment will be indicated by the red LED pulsing when the tape reflects into the photocell beam. To connect the balancer, first connect the cables to the balance velocimeter and the check velocimeter. Route the cables into the cockpit. Use care to avoid hot and moving parts and secure all cables safely. Plug the photocell cable into channel A. Plug the propeller end velocimeter into channel 1. Plug the check velocimeter from the rear of the engine into channel 2. Always exercise caution when working around the propeller. Treat every propeller as though the engine could fire, and never touch a propeller unless you are certain it will not fire.
Now it's time to balance the propeller. In a gravel-free run-up area, perform a normal engine start and allow the engine temperatures to stabilize. On constant speed models, be sure to cycle the propeller a couple times. Press the on button on the Vibrex 2000 and adjust the contrast using the buttons on the right of the Vibrex 2000 screen. Select Propeller Balance from the main menu screen. For information on propeller balance setup, press the number 1 context key next to the question mark. Press the Aircraft ID context key. Using the cursor right, cursor left, and the alphanumeric keys, enter the aircraft ID. Then push Start. Enter the propeller balance channel by pressing the prop channel context key. The check velocimeter is selected by pressing the rear channel context key. As the horsepower range is changed, note the sensitivity to weight for 1 inch per second also changes. If the sensitivity for an installation is known, it can be adjusted by pressing the Set Sensitivity context key. This capability is included to preset an exact sensitivity from a previously worked like-type installation. Both the weight, equal to 1 inch per second, and the phase lag can be changed to suit the installation using the alphanumeric keypad. When complete, push Start. Most balancing is done at a low to medium cruise RPM. About 2200 to 2400 RPM is usually sufficient. The live RPM will be indicated on the balancer's screen. When the RPM is steady, push Start. The balancer will automatically take a balance reading and display the reading for annotation. If the reading was suspect, it may be retaken using the Redo Measure context key. To acquire the reading for the check velocimeter at the rear of the engine, press Start. If the rear channel selection was none, the prop balance quality will also appear after the rear check velocimeter measurement. The X on the bar graph and the text will indicate the quality of the balance. If the warning text appears, consult the smooth propeller for a course of action. If the balance is already good, push Done. To obtain a balanced solution, push Start. Be sure to remove any pre-existing temporary weights between solutions. To see the weight solution, push Start. The correction is given in grams at a specific angle. Shut down the engine and install the trial weights. Use the digital scale to accurately weigh the trial weights. To implement the balanced solution, these weights are added on the spinner until the final balance weight is achieved. Rotate the retroreflective tape in line with the photocell beam. Using the propeller protractor, line up the arrow on the propeller end velocimeter body with the arrow on the protractor. Place the trial weight under the spinner screw closest to the angle specified by the solution screen. The closer the weight is placed to the specified location, the better the result will be for the second or any following runs. To begin run number 2, start and run the engine at the same RPM as the first run. In the main menu, press Propeller Balance, then Continue Balance Session. After the first run, the balancer learns the best response to adjust the trial weights. After the second solution, refine the balance by removing the trial weight. Adjust its angular position and weight.
Fit the weights to the outside of the spinner until the propeller is balanced. When the balance level is acceptable, the quality bar graph is displayed. This may take up to 3 runs. The balance goal is achieved when this screen appears, indicating that a final balance solution has been reached. Final weight addition of the trial weights should be accomplished according to the smooth propeller, which is FAA-approved source data. If, after balance, other vibrations are felt, they can be investigated using the analysis function of the Vibrex 2000. Measurements can be taken by hand-holding or rigidly mounting a velocimeter and acquiring a reading.
Since vibration on aircraft are combinations of the rotational speed of components or components tied to those rotational speeds, spectrum analysis is a means to filter the vibrations into known RPM and IPS values. These RPMs, when compared to known RPMs on the aircraft, will make it clear where to look for trouble, instead of using hit or miss techniques or expensive parts replacement. To take a spectrum, press Spectrum Analysis from the main menu. Select the channels from which the spectrum are to be taken using the appropriate context keys. Select an RPM range that includes the RPM of interest. The highest RPM range of 0 to 20,000 RPM is the broadest range and should be used if the RPM of the discrepancy is not known. Operate the aircraft in the regime that is most likely to reproduce the discrepant vibration. Press Start. Annotate the spectrum using the number or letter keys. Press Start to save the spectrum to memory. When viewing or reviewing a spectrum, the 10 highest peaks in the range of interest are shown. By pressing the View Peaks context key, the peaks shown are orders of the magnetic pickup or photocell. On reciprocating motors used in most light general aviation aircraft, the most pronounced peaks are ordered from the crankshaft speed. Order analysis is a very easy way to identify vibration peaks on reciprocating motors.
Propellers may be tracked with the optional Strobex blade tracker. Reflective tape strips are positioned on the blade tips. The strips are placed on the following blades further inboard, so when they are synchronized, they will appear as a vertical line. Plug the photocell cable into channel A. The Strobex is attached to the balancer using an interface cable that connects to the balancer serial port. The Strobex is attached to the interface cable. The Strobex is powered by a separate DC power source using a range of available DC adapter cables. With the engine running and the propeller producing thrust, the targets are observed by viewing the propeller tips as they advance toward the viewing position. Out of track can be observed in an obvious sense. A perfect track will produce a straight row of reflective targets.
To perform a Strobex track on a propeller, push the Track and Balance context key in the main menu. Operate the aircraft at the desired flight condition. To observe the track with the Strobex, select Strobex Track. Select the number of blades to be tracked using the number of blades context key. The blade tip targets will be aligned at one angle using the blade spread off. To return to the main menu, push Go Back twice.
The Vibrex 2000 is capable of functioning with a wide variety of printers and computers.
Select the information desired by using the context keys adjacent to the labels on the screen. Print Prop Runs prints the propeller balance runs and their corrections. Another Selection in the propeller balance menu is the logbook entry print. Press Go Back to return to the main menu. Print Balance Measure prints the balance measurements and the selected annotations. Press Go Back to return to the main menu. Print Spectrum prints the list of peaks or orders with their annotation. Press Go Back to return to the main menu. Printing may be done via a portable printer or IBM PC. Due to the large selection of serial printers and computers, it is impossible to address every setup for every device. The parameters that are used to download from the Vibrex 2000 for any serial interface is presented in the Vibrex 2000 user guide, to be used in conjunction with your PC or printer manual. The intent of this video is to answer commonly asked questions on the use of the Vibrex 2000. For more detailed information, consult your Vibrex 2000 user's manual.
Your Vibrex 2000 is built in the same tradition of excellence that you've come to expect from Chadwick Helmuth, the world leader in dynamic balance equipment.